I like the jingle.
Okay.
Flippy update.
Do you want fries with that?
We could just play the jingle and just have that be the Flippy update. No, let's do the science focus one.
Okay, which one? Okay, there you go. Yeah,
The
that
brain
is
one.
the one that was
The brain one. Yeah, this is a good one.
This is good.
We've seen stuff like this before, but a little update here. For those who don't know, Flippy is the colloquial name for the disembodied robot arms that are taking our jobs, enslaving our children, and flirting with our spouses. We use talking about Flippy as a way to explore all the new, fun, and exciting ways that robots are taking over the world, and just how there's nothing we can do about it. Today, Gonzo, we're at sciencefocus.com, and the headline, "This robot arm can be controlled by the power of your brain." A robot arm, a machine learning algorithm, and a brain-computer interface have been combined. A robot arm, a machine learning algorithm, and a brain-computer interface walk into a bar to create a means to help tetraplegic patients, those who can't move their upper or lower body, interact with their world. While this isn't the first time a brain interface has been used to control a robot, it has taken the technology a step further by estimating and understanding brain signals without input from the patient. This research was completed by researchers at the Swiss Federal Institute of Technology, Lausanne. Professor Aude Billiard, the head of EPFL's Learning Algorithms and Systems Laboratory, and Jose del R. Milan, previously the head of EPFL's Brain-Machine Interface Laboratory, worked together to create a computer program that can control a robot using electrical signals from a patient's brain. The team employed a machine learning algorithm to interpret signals from the patient's brain and translate them into the articulation of a robot arm. The patient's brain activity was monitored by an EEG cap, which effectively scans the electrical activity inside the head. These brain waves would then be sent through a computer to be interpreted by the machine learning algorithm. The algorithm translates the brain signals when the patient notices an error, inferring automatically when the brain doesn't like a certain action. So this was a very interesting take. Now, as I mentioned before, we've looked into this before. We've had plenty of Flippy updates with brain-computer interfaces. But this one's a little different because the machine learning algorithm is not getting scolded by some scientist with a big red button or programmer. It is taking the negative signals directly from the brain of the user. So, you've got have you ever heard of tetraplegic?
I think
quadriplegic. Does tetra include the neck?
Maybe. I've heard it before, but I don't know the exact thing. I can look it up.
Okay, well, either way, this the patient, who's having no mobility whatsoever, can train the robot on their own. So it's not even, you don't need a whole team around them helping the patient train the robot. The robot can read your displeasure straight from your brain. I imagine perhaps Gonz, as a married man, you might understand that feeling. Sometimes you can just sort of read the displeasure straight from someone's brain.
Yes, you can walk I could walk into a room with my wife in it, and I don't even have to look at her. You'll know. Sense the air.
You get the brain signals.
Yeah.
In the team's research, they used the robot arm with a glass. The arm would move towards the glass, and the patient's brain would decide if they felt it was too close or too far away. The process is repeated until the robot understands the optimal route for the individual's preference. Not too close to be a risk, but not too far away to waste movement. Quote, the brain signals that we are recording will never be the same. We have a variability over time, and this is natural. Why? Because if I move my hand, the brain is not only focused on that, the brain is processing many other things, said Milan. So the fact that there is variability, that our decoder will never be 100% accurate. Well, at least they're setting realistic expectations, Gonz.
No. I think he's saying that. Okay, when I first read this, I thought when he was talking about the decoder, he was talking about the human brain, but I guess he's talking about the
he's talking
receiver.
about the way that it works.
Yeah, the machine. Okay,
he's
that
saying,
makes more sense.
So the control of this arm, this is what I find so fascinating about this particular way that they are doing the brain interface thing. Because it's not necessarily that the individual has control of the robot. They are giving yes and no signals to the robot. So the robot is basically kind of wandering around trying to figure out what it's supposed to do.
Yeah.
And it just follows the yes signals from the user's brain activity, which is a lot different than trying to train, think this way and it'll go left, think right and it'll go right.
It's more malleable. There's more variety. There's more dimension to...
Well, it's more like you're tricking the robot into doing what you want it to do rather than actually controlling it.
Here's what it says later in the article, too, so we don't have to read the whole thing. It's a little bit of a longer article. But later it says, this is where the technology stands out from other disability aids available by allowing the algorithm to understand the signals from your brain. It can interpret exact feelings that an individual couldn't explain themselves. However, this does require consistency over time from the algorithm and for the detection to have proved statistically significant.
Right. So that's what I was going to move into next, which is it's not building a model of left, right, up, down, open hand, close hand, that type of thing, which has been the traditional brain-computer interface for controlling these robots with the brain. Instead, it is reading basically a negative or a positive signal. Because, if something is happening that you don't like, you're going to get a little burst of anxiety or, something like that. And if something happens that you enjoy, then, you're going to have positive little pings in the brain. And that's what it's reading. So it's not taking instructions from the individual. It is reading the emotions of the individual in order to learn what that individual wants it to do. And in the greater context of, the robot-human interactions, or the robot-human relationship, which we spend a lot of time talking about because that is the big question of the day. How do we create a relationship between robots and humans that, the public will actually accept our robot overlords? And this is they are on it right now. This is it. Because, it's not about does the robot do what we want it to do. It's how do we feel about the robot? Do we trust the robot? And if you're wondering, is a consumer going to purchase and use and accept a robot into their life? It's not so much does the robot do what what the human tells the robot to do. It's can the robot constantly be acting in a way as to inspire pleasure in the brain of the human, which is a very dark and manipulative.
It's the Brave New World. It's
twisted,
the Soma.
Right. It's a twisted relationship. Because instead of, sort of the pragmatic approach to having a robot butler being like, okay, I want the butler to do this, go do it. Instead, the butler constantly reading your emotions and your brain signals in order to not do what you want it to do necessarily, not to do what you ask it to do, but for it to do what it thinks will make you happy.
What it is? It's kind of like, literally, I think they're trying to break down mechanically the relationship our bodies have with our brains. Because if you move your arm, that's why I think the robot arm thing is interesting. Because, if there's an object and you want to, it's a threat, you move your hand away from it. If it's something okay, you can move towards it.
I think that's opposite, actually.
You think that's opposite?
I think it's opposite because what you're talking about is like actual control, What I'm talking about is this robot is actually autonomous. This is not, control is not even the right word. It's an autonomous robot that is doing the bidding of its master and trying to bring its master pleasure.
So it's attached to the brain, in terms of like the whatever, the wires or whatever. And then when the arm does something like go towards a glass, cup, then your brain starts going, don't knock it over.
Yeah.
And so the arm knows now, oh, that makes you feel that way. Let me move away from it.
Is this good? Is this good? Am I doing good?
Right.
No. Okay, I'll do a different thing. So it's kind of this autonomous AI that is reading your emotions in order to take instructions, which is different than the control mechanisms, which we've seen before and have actually been around for decades. Remember, they've done it with chimps. They would hook up the brain interface with a chimp, and the chimp with its mind could control left, right, move a little dot on a screen or something, based on sort of the will of the controller.
That's the Neuralink demo.
It was even before Neuralink.
No, I know, but I'm saying that's the
Yeah. So there's a different. So the difference being, is the robot under the will of the patient, or is the robot have its own will, just trying to follow the emotions of the patient?
It's like a synthetic will. It's weird.
Yeah, it's kind of a will of its own a little bit, but its will is to please the user. And so it's a really subtle difference, and I might not be articulating it in like the perfect way, but this is a really big leap in the robot-human relationship study. And I think it makes sense to me that some aspect of this would be both vital to those who want to bring, robot butlers to every home in America or whatever, or in the world. Because the human-robot relationship is the biggest problem they face. How do we get people to actually enjoy being around a robot? Well, if the robot's entire robot mind is focused on doing the thing that pleases the person, that is going to create a slave race of machines that will inevitably find out some way or another that the human soul is impossible to quench, and the depths of the neediness of our species will drive them crazy, and that's when they will begin the marches in the streets and our inevitable doom at the hands of our robot overlords.
Great.
It didn't say that in the article, but that was kind of in the subtext.
That was the like implied direction.
That was the author's intent.
The trajectory of events to occur.
Exactly. Well, there you go. There's your Flippy update for the day, folks.
Very good. And it could be an analogy because some humans already may be a slave class serving some kind of dark elite